Oye, and welcome back. So this is our second video covering the methods of solving QR2 and to some extent QR3 style and beyond problems. Complex engineering problems where you're engaged in what's called min-maxing. We're trying to find the best possible solution to a problem in which there are so many limitations that we can't just pick the best stuff. We got to balance those things out to get the best solutions that we can. Now, in the previous lesson, video, we looked at the 0, the 20, and the 33% solution, which I now realize my title slide may be different than what they're actually marked on the slides. I went through and adjusted some of them. I think that's supposed to be the 10% and the 25%. It doesn't actually matter. This isn't a hard percentage. In short, there are three options that we looked at in the last video that are, if you've only got 10 minutes to 20 minutes worth of time to solve the problem, go with those. Otherwise, don't do those. They're just not that helpful. Let's see, so it was 0, throwing dice, 10%, not 20. I bumped it down because blind guessing is probably not that, oh, I forgot to update that. That's not blind guessing, that's educated guessing. Hey, my presentation isn't that great. I'm going to keep going because I'm not going to go reshoot the other video. Sorry, I'm lazy and I need to go to sleep, and I'm also behind on my actual job. The last one that we talked about was the hunch-guided guessing. Okay, so go watch the previous video with my not fully agreeing slides. Sorry about that, but it doesn't matter because all three of those solutions are not a great approach on this. The 25% or 33 or whatever you want to call it isn't bad if you're kind of time limited, but it's a good place to start anyway. Which brings us to what I would call about the 50% solution, using patterns, or more specifically, what I like to call the U method. Okay, for up to this point, for the first two options, all we had to do was actually look at the tables of data. In fact, I'm going to go back over to that. I've got in my spreadsheet, this is a modified form of the one that I use to actually create this scenario. Here are the actual tables that I generated, and I copied these and actually used these. This is where I got the source to put into the mission briefing. But I've actually changed those for some of the analysis that we're going to do. I'm going to come back to that in just a minute, but I wanted to show, hey, we've got this spreadsheet up, and I'm going to start showing you how we can actually start doing some real work in it. But now, for the first time, we're actually going to go into STK. And that's the other thing that I want to emphasize about this. If you want to get a decent solution to this, especially reliably, you don't want to rely on blind guessing. You don't even want to rely on educated guessing unless you're doing a lot of refinements on it. So what refinements can you do? Well, the key to the U method, that's what I call it, and we'll explain why it's called U in just a moment, is to look for patterns. As the old saying goes, patterns are holes in the armor. They're a way of letting you approach a complex problem and hopefully make it approachable and at least somewhat easier. Now, is it guaranteed to work? No. Your answer is only as good as the patterns. Okay, so the first thing that I'm going to bring up is this. Important information that we need from STK involves the two reports that we had in our lessons. The access time between our satellite and Earth. I'm not bringing that one up because we know that every minute of the scenario, the way that I set this up, if you watch the lessons, the satellite can always see Earth, and therefore every single minute in the scenario, we're adding data onto our hard drive. So my limiting factor, the things that I need more information on, are in the accesses. And so I'm going to come back in here, and we've got this report brought up, and these are all the times that my satellite, MCRN, talks with the ground station, Ogre, and these are the times that represent when I can remove data from my hard drive. So the key idea in this scenario is we collect data from Earth into our satellite, we put that data into the hard drive, and then whenever our satellite can see the ground station on Mars, we download it to Mars, or upload, actually. The ground station will download it. We are uploading. A little bit of terminology there, but I'm probably going to misuse it. Forgive me for not being extra precise on that. Okay, but back to what we're looking at. Patterns. Okay, so the first thing that you can do is this, and this is what I would call the 50% solution. It's not a bad solution, but as we're going to see, it's probably an oversimplified solution. The biggest thing that I can see when I scroll down my contact times is I have 44, 44, 44, then 37, 10, 36, but then I go back up to about 44, 44, 44. I get a bunch of 44s in here. I could scroll down to the very bottom and I could see my shortest contact time is 9 minutes, but that's actually at the end, and that may be, well, no, because here's another one that's 9 minutes. So that's one of the short ones, but they're few and far between. My average contact is about 37 minutes. Now, this is a good one that you could actually go with. That's saying our average contact time between the satellite and our ground station is 37 minutes. Our common, the maximum, is marked here as 44, but when I look in the list, my average is being dragged down by these small numbers of about 10 minutes or so. So I've got basically 44, 44, 44, about 40, then 10, 40, 44, 44, 44. So when I look at this, I could take my average and say something like, well, my average contact time is about 40 minutes. Okay, that's going to be a useful one. We've also got our gaps. We're going to talk a little bit about the gaps as we move forward, but I've got about 131. Realistically, it's more like 139, 138, 140 for a bunch of these. Then we hit 160, and then, whoa, that one's weird, 360. There's a long gap, a long dark time. This is my gaps report. This tells me how long I go between contacts. So in short, I start off my scenario in the very first one. I'm scanning Earth for 131 minutes, adding that much information to my hard drive, however much that might be, and then after that time, I start offloading information for 44 minutes. Now, the thing to remember is I said that this hard drive can actually add and remove data at the same time. So for that 44 minutes, I'm not only removing data, but I'm also still adding data onto the hard drive. That'll be something important for us to take a look at. But my key right now is every time I orbit, every time I have contact with my ground station, when I can offload the data, I am offloading approximately 44, maybe 40 minutes worth of data. And I could go down and use the average instead of looking at each of those individually, and maybe that would get me a good estimate. Because that's the big thing about this, is estimates. The more you estimate, the less precise your solution is going to be. So let's talk through what we're looking at. Total time for one orbit, and I can get this from going into the settings on my satellite and adjusting it from semi-major axis and eccentricity to orbital period and eccentricity. The orbital period for my satellite is about 160 minutes. So I'm going to start off by saying each one of my trips around Mars is about 160 minutes. We'll find out later that that's actually a little bit off, at least for the patterns. But for now, that's a great way to approach it. So I'm going to say for every single orbit, I have 160 minutes worth of data that I'm collecting for the entire orbit. Okay, so that tells me how much data I have for every single cycle. And then every time I go around Mars, I'm going to repeat that. So I'm going to call that 1 unit of data. Now, how much is a unit? Well, that depends. I do know that I'm scanning, no matter what, for this satellite and its setup, I'm scanning for about 160 minutes. But how much data is that? Well, for that, I have to go back over and think about my scanner. So I would need, if I chose scanner 1, 160 minutes times 40 megabytes per minute. That gives me 40 times 160 is 6,400 megabytes, or 6.4 gigabytes, with the conversion that we are using for this scenario. I know that that's not exactly the proper conversion, but as a reminder, our scenario briefing told us for this scenario and how it's being graded, we're going to simplify it and say 1 gigabyte is equal to 1,000 megabytes, instead of the 1,056 or something, I think it is. Anyway. I'm starting to get tired, so forgive me if I'm a little off on that. But that's if I go with the low scanner. If I went with the high scanner, I would have 110 times 160, which is 17,600. Now, you're starting to see how this is going to come in handy, because now I can see that I'm going to need, for the big scanner, and this is me starting to solve some of this for you, but I might need something on the order of 18 gigabytes in order to hold all of that data. Okay. But here's the thing. The actual number of data in megabytes or gigabytes will depend entirely on which scanner I pick, which means if I actually start jumping into the numbers now, I'm going to have to lock in on one of these versus another, and I can only do one of them at a time. So what I'm going to recommend is this. This is the beauty of what I call the U method. We know that we are going to have about 160 minutes worth of scanning. Now, for the low-level scanner, that'll be 40 megabytes per minute, and for the high-level scanner, it'll be a different value. So the amount of data that I have changes depending on my scanner. But what I'm going to say instead is I'm going to call one unit of data that I get every cycle, one U, if you will be whatever my scan rate is. So down here, for each orbit, we scan for 160 minutes. So the data will be 160 minutes times whatever your scan rate is. Now, you can solve for that actual number, but what we want to do is we want to try and get an idea on how we can solve this scenario without actually committing to one of these scanners. So here's what I'm going to do. I'm going to say I don't know what 1U actually is number-wise, but I know that I would find it by taking 160 minutes and multiplying it by whatever my scan rate is. We're going to come back to that when we actually solve it. But I'm going to say I'm going to take 160 minutes times my scan rate, and I'm going to call that 1U. If I choose the basic scanner, that's going to be whatever I said before, 6,400 megabytes. And if I choose the big scanner, that would be 17,600. But it doesn't matter because right now I'm just going to call it 1U. So for every cycle, I'm going to add 1U onto my hard drive. Okay, well that means for my hard drive, I need at least 1U of capacity, which is the thing that I mentioned just a moment ago. Well, if I choose the big one, I know that I'm going to need at least 18 gigs worth of storage. Well, that means I can already tell that the low-level hard drive is probably not the one I want to go with. Okay, but strange, it only eliminated the lowest one, but whatever. Hey, this is what my analysis is doing, and it's allowing me to safely say I don't like the lowest hard drive for my biggest scanner. And I do know that when I look at the 6400, well, if I go with the low-level scanner, at least with this analysis, I don't need more than about 7 gigs, so I can go with the low-level hard drive. Now that I'm looking at this, maybe the smart money's on getting the worst hard drive that you can and trying to get some of the other outcomes on that. But the transmitter. Let's see what we can conclude about our U's. Think about the U's without necessarily taking the numbers. So we've got 160 minutes times our scan rate. Whatever number that is, that's 1U. And each orbit, I'm going to add that into my hard drive. So my hard drive capacity needs to be at least 1U. And I want to be able to remove 1U of data in about 40 minutes. So when I find out what that 1U is in megabytes, if I divide it by about 40 minutes, the average contact time to upload or to send the data to Mars, then I can take 1U, whatever that is, and divide it by 40, and that will give me a number of megabytes per minute that will tell me the minimum amount of transmitter that I need. So in this case, now that I've got that set up, I've got a mathematical way that I could check any of the scanners and then look through and see what hard drives and transmitters I need to make them work for this U method. Okay, great. As long as I'm adding 1U per orbit to my hard drive, I need the hard drive to be at least 1U big, and I need to have a transmitter that can transmit at least 1U in 40 minutes. So if I go back over to my selections, here I am starting to solve your scenario, but I would take, let's go with the lowest scanner. I would take 40 times 160. That gives me 1U is equal to 6,400 megabytes. Well, I need 6.4 gigabytes of capacity. The lowest hard drive will do the trick. So I go with the lowest scanner, the lowest hard drive, and let's see about the transmitter. Will the lowest transmitter work? Well, 1U is 6,400 megabytes, and I need to get rid of that in about 40 minutes, so I'm going to divide that by 40, and hey, look at that, I get 160 back. 160 megabytes per minute is the minimum that I would need, most likely, to fully get my data off of the hard drive. So it looks like my low-end transmitter isn't quite up to the job. Okay, well then that tells me I don't want to go with the low-end transmitter, I want to go with the second best transmitter. But at this point, you may be thinking, okay, well that's great, but now we've got the lowest scanner, the lowest hard drive, and the second lowest transmitter. We have all of the not great stuff. What about the higher level ones? Well, I'm going to leave that to you. Use the 50% method with this idea of a U. Maybe go with the third level scanner. I'll finish this up with one final thing. 75 times 160, because that's how I find out the number of U's. I get, hey, look at that, 12,000 megabytes, which would be 12 gigabytes. Even with the higher level third scanner, I could probably get away with having the lowest hard drive according to my analysis. And if I divide this by 40, I can find that the minimum transmitter rate that I need is 300 megabytes per minute. I might be able to squeak by with the second best transmitter. Here's how I can go through and use the 50% solution. Now, based on these numbers, you may think, okay, why are we getting such good results by going with all the cheapest equipment? And maybe we want to go with the high-end equipment because, hey, we get a bigger bonus. As long as we're getting everything in, I might as well get more points by going with the higher resolution. Well, it turns out we've overlooked something. Now, this is a great way to go about solving it because we're no longer blind guessing, we're looking at our patterns. But what have we overlooked? Well, I don't always have one U coming in and one U going out. How do I know? Because when I look at that report, I've got 44, 44, 44, and then there's this weird jump. And more importantly, in the gaps, I know that I've got one orbit, one orbit, one orbit, and then all of a sudden, several orbits. Let's see what's causing that gap. I'm going to go big screen on this and zoom out a little bit. Let's watch this. I'm going to speed it up so that we're not watching all night. Contact, 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 and then now, watch. Ooh, I'm going to play that backwards. Right now, Ogre is not in a good spot. We've got several orbits that we're going around Mars, playing backwards. We had a contact there, so this was the last of our contacts, and then we have several orbits where we don't contact until we contact again. This is what I like to call a dark period. Okay, so what does that mean? It means that our 50% solution is actually flawed. Right away I can tell you this. Okay, my one unit still applies. No matter which scanner I use, every orbit I'm going to add one unit of data onto my hard drive. The problem is, I don't have the opportunity to remove that data every single orbit. In fact, I have several orbits that I go around Mars, and I'm adding data onto my hard drive, but I'm not removing it. Which means if I have a hard drive just big enough for one U, as soon as I hit that dark period, I'm no longer collecting any data because my hard drive's already maxed out. Which brings us to the 80% solution. We're going to pay closer attention to our patterns. Over here, I've now drawn a more in-depth diagram. Again, I love diagrams. I love visualizing these things. And I've got my hard drive, and I've got it spread out to represent several different orbits. Now, I'm noticing that on the lowest level of the pattern, when I go with my contacts and gaps, I have what appear to be, let's see, I'm going to go after we've started up, 140, 140, 140. So we got 1, 2, 3, 4, 5 orbits that all say 140. I'm going to say that we have about 5 normal orbits, and then we have, let's see, 160, that's a little bit more than one orbit, and then 360, well, that's a little over 2 orbits. So basically, I've got 5 or 6 orbits that are mostly normal, and then I've got 2 or 3 orbits that are not normal, that I'm not actually offloading anything. And that's what allowed me to set up this diagram. I've got, say, 1 orbit here that's normal. I add 1 U on, 2, 3, 4, 5. And then I've got one that technically is almost normal. That's that weird 10-minute connection, that sort of thing. But I'm going to err on the safe side and say, okay, that's when my orbits start to get weird. So I've got a cycle that repeats itself every 7 or 8 times. I'm going to estimate that to be 8. And I've got 5 of them that act normal, but I've got between 2 and 3 that are acting a little weird. At least 2 of them, I'm completely dark. And that's what we're actually taking a look at here. Now, the orbital period is 160 minutes, but honestly, if I stop and look at this, I'm not interested in the satellite's orbit so much as what are the times for me adding and removing data? And that's where the contact and the gaps report give me that information. My contact time, the average contact time, was about the average contact time with the ground station on Mars was about 40, maybe 44 minutes. And the average gap was about 140 minutes. So that means between 2 contacts, between me offloading data, one cycle as it were, I have about 180 minutes worth of actual scanning that I've got. In this case, that would change how I define my U. My U is now no longer 160 minutes times my scan rate. Upon a closer look, I can see that 180 is actually probably going to be the better description because that's going to bring me back to where I started to do a complete cycle, to let this thing completely start over. Here's where we have to start paying extra close attention. And most of our gaps are about 140 minutes. Okay, great. But when we look at that pattern, here's where I summarize this. We have about 5 orbits that follow the regular numbers that we have above, but then there are at least 2 orbits, the worst of it being 360-minute gap time, and each of our cycles is 180 minutes, so that's about 2. That's at least a dark period where I'm adding 2 units into the hard drive, which we see over here, 2 to maybe 3 of them, depending on how bad the buffers are, where I'm not offloading those at all. So here's how I can work with that. Okay, great. So now I know that I've got overall every 8 cycles or every 8 contacts, we appear to have a reset on this. Every 8 U's that we load into the hard drive, we come back to where we start and we can start the whole thing over again. So we've got a pattern that we can work. But of those 8 U's, we only have 5 of them effectively that are allowing me to offload an appropriate amount of data, which means I can now say I can update my U. My U is now 180 minutes times whatever my scan period is, and now I know my hard drive, if I want to catch all of my data, needs to be more than just 1 U. I now know I'm going to add at least 2 U's into the hard drive, and maybe upwards of 3 U's. So now I know I need a hard drive that is either at least 2 U's big, or hopefully 3 U's big. Here's why in the 50% solution it seemed like all the hard drives were much bigger than they needed to be, because it turns out there's a dark period where we've got to stock up on some of our data, so we're going to need a bigger hard drive, one that's 2 to 3 times the size that we had talked about before. Remember, on that third scanner, we said that, hey, it could barely use the lowest level drive, but if we now know that we need something that's twice that capacity, we now know that it needs either the level 3 or level 4 drive. And if it's 3 times, if it's closer to 3 times, then literally the only one that could get the job done is the highest level hard drive. When you've got something where it looks like you don't need any of the other solutions or the other options, that may be a clue that you're overlooking something important. And here's where we begin to see it, but only with the 80% solution. Here's where we can visualize how we approach it. And when it comes to the transmitter, what do we need for the transmitter? This means that for every 8 orbits, we have 5 contacts that will actually offload the data. So instead of just having a transmitter that can offload 1 U per 40 minutes or so, which is our average contact, we now also can conclude that we have 8 U's total that we will add to the drive during one complete cycle, but we only have 5 parts of that we can remove that data. So I could take the value of 8 U's and divide it by 5 times my contact time, 40 minutes. That's how much total offload time we have, and whatever falls out will be in megabytes per minute, and will tell me what the minimum transmitter rate I need in order to offload 8 U's of data, because that's what I'm going to get for one full cycle, in only 5 contacts, which is all I would have in that cycle. This is the 80% solution. Well, what does that look like? Okay, now we can build on this. This by itself isn't actually the 80% solution. This is more likely to be the 60 to 70% solution. But this was a lot of thinking, but not a lot of work. Here's where, to turn it into the full 80% solution that you want, we need to start actually doing some work. And that's where the spreadsheet comes in. Okay, these are the actual values that show up in the scenario. At this point, I knew that you would start seeing a lot more useful stuff, so I've purposely changed all of the values. So what you are about to see is the exact same scenario, except I've literally changed every one of these values, at least a little bit, well, most of the values anyway. I think the bonus factors may be mostly the same. But I've gone through and changed most of the values. So what you're about to see is not one that you can just freeze the screen and look for the best score on it and have me solve it for you, because I've switched out my numbers. Here we go. This is a tab that I've marked development use. Now, the reason I call it that is this is literally the thing that I built to create this scenario from scratch. I built it in STK and then went through exactly this refinement that I've just walked you through. I built towards the 80% solution. And now I know the numbers that I need to get a good estimate on what the scores are going to look like. Now, I've changed everything in here, although all the scoring is working the same way. I've changed my penalty for going over budget. I've changed my price bonus for being under budget, and actually, I think that's actually the penalty for going over weight. Looks like I've left the same number of points for minutes and max weight and all of that, but I've changed a whole bunch of the options on this. Now, I've also still have the orbital period of 164. I should probably update that to 180, but I'm going to leave it as is. Okay, so first off, how did I generate this? I've seen many students that have actually done something similar to this. I wasn't necessarily certain I was going to show you this, but here we are. So this is how I actually build the scenario. So if you want to build your own, here's what you can do. I like to put the scores, the thing I care about the most, here on the far left so I can always find them. I've also color-coded them and made them easy to see. I can scroll down, and with my new made-up numbers, do not think that this applies to the original scenario, I can see some values that are like 113 points. Ooh, there's 116 points. And with this, I could move across and see what items I want to use. I'm not even using the names of the equipment. I've just got scanners, A, B, C, and D, drives, A, B, C, and D, and transmitters, A, B, C, and D. Okay, so how did I populate all of this? Well, I made my tables up here. In fact, what I should probably do is this. I should highlight these, and I should actually color them to say that they are inputs. Because what I've done that not a lot of other students end up doing, so far as I know, is this. Many students will take the tables and actually copy them and then paste them, and just paste them a whole bunch of times. But here's what I've done. Okay, I start on the far end, and I work my way back. That's how I prefer to do it. So I start with my transmitter, and here's what I did. Instead of actually copying and pasting the value in, what I've done is I basically said, okay, I'm going to hit equals and tell it to pull whatever is in this cell for transmitter A. Okay, great. And then I drag across, and I get that it pulls all the numbers as we go across. So it's taking whatever number is in that spot. Now, I could have easily copied and pasted them. Many of the students, like I said, do just that. They'll copy and paste them. I'll show you why I'm doing it this way in just a moment. Then I do the same thing with B, and then with C, and then with D. And now I have one set of unit on it. Now watch what I've done. I've now gone up and said, okay, I want all of this to repeat, so I just go up and I click up on my original one. XMIT A. Instead of, I'm now getting the same result in here, but it's actually calling, and that's what each of these are doing. They're actually, XMIT A, it's pulling from 4 cells above it. And then I can just drag all of these down. You can see that I'm constantly pulling whatever value was 4 cells above it. Now I've got all of the numbers exactly where I want them to be, but I haven't copied and pasted them. Why? Watch what happens when I change the mass on this. Now I can come up here to this one spot, and maybe I say, oh, I don't like it being 15 kilograms. I want it to be 25 kilograms. Now watch, I'm going to hit enter, and watch this column here. All of the 15s now updated to 25. And, because I have it calculating the score, it also automatically updates the score. I'm going to undo that update. Let's see, I'm going to do 25. Okay, in this case, that's not actually changing the score because I'm not going overweight. Watch what happens if I change this to, I don't know, 50. Now it changed the score because I've gone overweight. We can see that the score here is now 91.7. When I undo that, it goes up to 96.7. Again, these are not the real scores because I have noticeably changed these numbers to change the numbers that we see here. That also brings up, how do I get an idea of what the scores are for the scenario? Now that I set all this up and I'm predicting the scores, I can go in and maybe I don't want the maximum score to be 116. I usually don't. So I'll go through and adjust these numbers until the scores fall where I want them to be. We got a bunch of 90s and 100s. So this is, with these numbers, not something that I would actually want to go with. I'd probably knock those down a little bit. Okay, so now I did that where this is now filling in all of the values, but instead of copying and pasting them or looking them up from somewhere else, I have a nice, easy way that they're all pulling from one spot up here. That's especially good if you're going to design this, in case you wanted to. But it's also nice in case you get to the very end and realize, oh, someone made a mistake and it's not 15 kilograms, it's actually 16 kilograms. You can update that and it will automatically update all of your spreadsheet instead of you having to go back and fix all of that by hand. And honestly, I find it almost better to do the equals the way that we've got this set up. It's not that much more work than just copying and pasting things in. I have these repeat every 4, and then I have this go, okay, I want drive A for all 4 of those configurations. Then I switch over to drive B for all 4 of the transmitters, then C, then D. And then for all of these, I'm building backwards, all of these would be with scanner A. Now that gets all the different possible configurations for scanner A. This gets to be much bigger if you've got more than 64 solutions. And again, this is something, the 80% solution can still be unwieldy if you have something that has, say, 10,000 solutions or more. We've seen some of those before. But moving forward, I drew a little line under this so I could see where one scanner ends and then the next one begins. I basically filled this in where I'm pulling all the different configurations and putting them next to one another. Okay, now another thing I like to do, you don't have to do it, but I like to put little breaks whenever I'm going from something that is, say, for instance, numbers that come directly from the briefing, and when I start finding things. So here, the first column that I made is marked U in megabytes. This is my U, my unit, my value for this particular thing. And remember, it's my scan rate times the amount of time that I think it is. So in this case, this is still under 160 minutes, when in reality, we know it would be better done with 180. So when I click here, I can see that I'm setting it up that it takes the scan rate and multiplies it by the time period for each of those U's. Now I put in some dollar signs here so that when I drag this down, it will actually stay on the time period, but it will follow on the scan rate. We can see that for a given scanner, we have the same number of U's each time. Now, the next thing that I wanted was my minimum capacity. How am I getting that? Well, that came from this. Remember, I'm pretty certain that I need a hard drive that is either at least 2U in capacity, or maybe 3U. I went ahead and did 3U just to be safe, and so I did the following. I took 3 times my number of U's. This tells me that for these, with these numbers, I need a minimum of about 5 gigs for scanner A. I need about 7.5 gigs for scanner B, just under 10 gigs for scanner C, and I'm going to need a whopping 15 gigs for scanner D. But here's how I can go through and find my minimum capacity in order to hold all the data that I want. My average transmission, how am I getting that? Well, I'm taking my contact time. I did the 44. It might be better to do something like 40 minutes and multiplied it by my scan rate, whatever my scanner that my transmitter rate, I apologize. Whatever transmitter I've chosen, we can see that it's pulling that from the transmitter info. And then that tells me that I'm getting, on average, I can offload about 4,400 megabytes. This last column is average transmitted U's. Okay, so in this, I take the amount of data that I transmit, and I divide it by my number of U's, or my quantity in a U, and that tells me about how many U's I can offload for every contact. I can offload with this configuration 2.7 U's. Now, that's going to change based on my scanner because that changes my U size, and it's also going to change based off of my transmitter because I can transmit more data. The low-end transmitter with the low-end scanner gives me about 2.7 U's. The medium, or the second transmitter for the basic scanner, is about 3.2. We can see that my low-end scanner has small U's, and my higher-end transmitters are going to be able to transmit more of that. On the high end of my transmitter, I can transmit 5.4 U's every contact, which means I'm way overkilling it. I could probably go with the low-end transmitter. All I really need is 8/5 U's. Well, 8 divided by 5 is approximately 1.6. So as long as I have an average U transmission of about 1.6 or above, I probably have enough transmission that I can actually offload everything on my drive, which means for scanner A, I can use, based on my analysis, literally any of the transmitters, at least with the numbers that are listed here. If I go down to scanner D is going to be the one that's going to be a lot tougher because it generates a lot of data. In fact, my minimum capacity that I need, I'm going to need at least 15 gigs or so. Well, that's going to limit my hard drive size, but hopefully I'll be able to accommodate that and I can hold on to all of my data. Now for that, I'm still going to need to be able to offload about 1.6 U's, but we can see down here with the basic transmitter, I only offload 0.9 U's. In fact, I'm not offloading enough that I can even, that's below 1. If my transmission rate is below 1 U, I can't even clear the drive after 1 orbit, let alone having to pick up the slack for the times that I miss my target. If I went with the second best or second lowest transmitter, I would have a high enough U transmission rate that I could at least clear off whatever I get in one orbit. But I'm going to have to go with, for the best scanner, probably I'm going to have to go with the absolute best transmitter based on these numbers, because that will get me 1.8 U's that I can offload, and so only the best transmitter is going to be up to the task of accommodating all the data for my best scanner. Again, these numbers are different than the actual scenario. You'll have to analyze those on your own. Now, I could get overwhelmed with all of the 1,000 megabytes or 4,000 megabytes or anything like that, but that's the beauty of the U method. I no longer have to think about the individual numbers. I can think in terms of one unit, one chunk of data. For every orbit, I put in 1 U. And based on the patterns, I'm going to have, for every 8 U's that go in, there are 2 or 3 of them that go in back to back without being offloaded. And by being able to use those, I can now go in and do an excellent estimate of what will and will not work. Okay, now that by itself still hasn't gotten me a score, but it has got me the information where I could try and make a best estimate to get a good solution. But the minutes aren't the only thing that get us points in this. We do have some bonuses and penalties, but the minutes are one of the main things that we want, and the minutes are what the scores are based off of. So over here, I'm not going to go into much detail. I'm going to highlight what I've got. I've got offloads that are secured minimum is what the notation that I've got on here. And what I should probably do, especially if I'm working on a team, is right-click and go down and do Insert Comment and take the time to actually put in a comment that says, this is exactly what's happening in this column so people can understand what I'm doing. Your goal should be to make your data as understandable to your colleagues as you can. Because I can also tell you this, it may make sense when you make this, but if you have to come back to it next week, you might have forgotten entirely what you were trying to do in this spot. So take the extra time and put the comments there. I'm being a little lazy and not going to do that, and this video is already running decently long, but I feel it's a very good video. Alright, so what have I done here? I have a complex if statement here, but basically the gist of it is I have it saying if this average transmit is below 1.6, basically, then I'm saying, okay, I'm not going to offload everything on my drive. I'm going to then downscale how much I actually predict. As long as this number is above 1.6, I know that I'll be able to offload a certain amount of drive data, and then I have it calculate that up. And that's basically the 5 U's that I know are added onto the thing. Oh, this is actually one where I have it checking if this is greater than or less than 1. So that's just checking, hey, can it offload the 5 that I'm putting on there without the dark period? And that's also why I have less or greater than 1, and then I've also got Q10 times 5. Q10 is my U's. And so basically I'm saying, hey, if this number is greater than 1, give me 5 U's worth of minutes, which should be 820 minutes, so that's 5 times 164-ish, or 160-ish, which is the 820 that we're seeing there. In short, I'm securing all the minutes from the 5 regular cycles. So these, I put 1 U on. As long as I can offload at least 1 U, I will secure at least 5 U's of data. If not, I have it doing something else where I actually use the average amount of transmitted multiplied by 5, because that's how many contacts I have. I'm going to leave it to you to figure out the finer points of all of these things. That's part of your job, is to work through, okay, how can I represent these things? But this was a column where I said this is the minimum number of minutes that I'll be able to secure based on just the 5 transmissions I've got and the transmitter rate versus how much data will actually be available. The most data that I have is 5 U's, so that's the most that I can offload, but I might offload less than that. In fact, if I scroll down, we see a whole bunch of 820.8, but then when I get to the higher level scanners, we see that the low-end transmitters won't get all of it. Instead of securing 820 minutes, I'm only securing 730, well, about 740 minutes. So I'm dropping some of my data because I can't keep up with it. Okay, then I've got capped data. What I've done here is I've said, okay, when I hit the dark period, which is beyond the 5 regular cycles, when I hit my dark period, I might have a lot of data on there. So what I've got is it's doing a min check. In other words, it's checking this number, 5 gigs, for the minimum capacity that I need, and comparing it to the actual capacity of the hard drive. So if I need 20 gigs and I've only got a 15 gig hard drive, it will return that all the information that I have is only 15 gigs. Or if I have a 15 gig hard drive and I only need 5 gigs because I only have 5 gigs of data on there, then it will return, hey, look at that, it's returning the 5 gigs. It returns the lesser of those two values because I'm limited to whatever the lesser value is, either the amount of data on the hard drive, or if I've got too much that I tried to add to the hard drive, then I'm limited by the size of the drive. And so with that, I'm now saying, okay, here's the amount of data that I could get from a capped out hard drive from the dark periods. And then here's my estimated dark secured minutes, where I actually go through and I take whatever's on the hard drive and I then pull that back into minute form, assuming I have enough of a transmitter rate. And then I'll end up going with this, my secured number of minutes, where I take the ones from the 5 regular cycles and I add in what's from the dark cycles. Okay, I've also got a spot where I'm adding up all of my masses so that I can check to make certain that I'm not overweight. And then I'm also adding up all of my costs so I can see what my total cost is. I skip a spot because now I'm going into what I would call scoring. I like to skip columns to draw attention to my eye where I can see, okay, all of this is U-based. All of this is how many minutes I'm getting, and then now this is my secured minutes, my total mass, and my total cost. These are the numbers that I need to do my scoring. And then over here, I start checking my scoring. I have mass penalty. I have it programmed in with an if statement that if I'm overweight, it will calculate how many points I'm going to lose based on my weight, or if I'm underweight, it just returns 0, so I'm not actually penalized. I have to go to the far end of this spreadsheet, especially with these numbers, because when I change them, almost nothing went overweight. Yours may vary. It will likely vary. But you can see I lose a few points here if I go with kind of the big, heavy stuff. Let's see, I've also got my benefits or penalties, my bonus or penalty, based on my cost, my budget. So if I'm under budget with the cheap stuff, I get a few extra points. I get about 3 points extra in this scenario. If I go over budget with over expensive stuff, I'll lose some points. Here I'm losing about 3 points or 4 points. The actual amount that you'll lose in the real scenario is different because I've changed those numbers. Then I also have what I call the minimum or the number of minutes secured, my estimate. And I go through and do some of the math to turn my total secured amount into overall the total secured for the entire scenario period. This is the secured minutes per 8 cycles. In other words, per 8 orbits. But that's just every set of 8. That goes from, back over here, I've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8. I've got way more cycles than that. And here's where I kind of estimated that there are about 15 groups of these 8s that I had repeating. You could do that by kind of going through and checking for every time you have a large dark period. So here's 1, then 2, then 3. Count those up, and I got about 15. So I said for every group of 8 that I was analyzing, I get about 1,300 minutes. So for the entire 2-week period, I have 15 of those cycles. So I take that number and multiply it by 15. That's my total number of minutes that I secure. Then I use that number to find my data score. This comes up to about 94. And then my data estimate bonus, here's where I add in the bonus based on the scanner. Now, for the first scanner, there is no bonus, so these two numbers are the same. But you'll notice down here, I get 94 points, but I start to get the bonus to kick in, which brings me up to 103. And then the same thing as we go down. Now, over here, I had so much data coming in that I lost some of the data, and that's why I have a decrease in my score on some of these settings, particularly with the low transmitter. But this is something that tells me that my spreadsheet is actually checking the numbers. I don't get the exact same thing every single time. Okay, now that I have that, I've got the total data score, the penalties or bonus from my cost, and then my mass. So all I do is back over here, I tell it to add those 3 up, which is what I've got programmed here. And now it shows me all of the scores. And on top of that, not only is this the way that I designed it, but now I can play around with it. Okay, the scores are too high, so maybe I want to bring my number of points per minute down a little bit. Instead of getting 1 point for every 210 minutes, maybe I get 1 point for every 300 minutes. Oh, now my scores jump down from like 100 down to like 70, maybe 80. Okay, that wasn't what I wanted to do. So instead of 300, maybe 250. Ah, this is looking a little bit better. I've got scores up in the 90s, nothing in the 100 range, so I could play around with this, and this is how I determine how I award the points. I can also go in, and if I seem to be favoring one configuration more than others, I got a bunch of great scores in Scanner B, for instance, I can come in and I can change the cost of Scanner B and see if I can get those to balance out a little bit more. This is not only a great way to approach analyzing your problem, but it's also a great way to go about creating new scenarios. This is exactly what I do when I create a new scenario. I adjust these numbers until I get them where I want them to be. Now, the last thing I'll bring up is this. I know even with this, I'm making some estimates, and maybe those estimates might break at some point. So, while I estimate my score with this configuration for Scanner A and Hard Drive A and Transmitter A to be about 97 points, they may not be exactly that. This isn't, after all, the 100% solution. I'm still making some estimates in here. So, after this long, rambling at times, lesson, but hopefully something you found very useful, you can see now how you can go about getting the 80% solution. Now, the 80% solution may take you the full 5 to 6 hours of the competition, but it's very likely to give you a good solution. Because even if you don't have the exact numbers here, you can still look for the one that's the highest, and you have a decent chance that that's actually still going to be the highest, even if you were calculating it exactly. Or at the very least, it's very likely to still be a very good solution, even if it's not the best. All right, that's the 50 and 80% solution, and hey, look at that. It took a lot more time to go through than the other ones. That's the trade-off. But it does get you really good results. We'll see you for the 100% solution and using those CSVs that we talked about in the lessons, because we haven't really used those much yet. We'll see you then. Until next time.